In this probability lesson, we're going to design and run simulations based on what is called the Monte Carlo method. The Monte Carlo method was developed and named by Stanislaw Ulam, hopefully I pronounced that correctly. He was a Polish-born mathematician, and he named it after the well-known Monte Carlo casino in the Principality of Monaco. Now, a Monte Carlo simulation uses repeated trials to produce experimental probabilities to estimate theoretical probabilities. And it's used because there are some complex questions involving risk and decision making that cannot be answered with other mathematical theories, but can be answered using a Monte Carlo simulation. There are 3 steps to the Monte Carlo simulation, and the first step is 1 is to determine how the situation will be modeled, 2, define what constitutes a trial and what will be recorded, and 3, specify the number of trials that will be run and how the estimated answer will be obtained. What might I simulate with a Monte Carlo simulation? Maybe I would like to flip a coin 5 times. The problem is I don't have a coin. So maybe I would use instead a die, and I would say that evens represent the heads and tails represent the odds because they both have the same probability of 1/2 on that. Maybe a deck of cards, 52 cards, where black is heads and reds is tails. Maybe I have a spinner where 50% of it represents heads and 50% tails. Well, I'm going to do a lot of simulations, and then when I do it with my students, I want them to be able to do this. So what I want them to use is their graphing calculator. Now, I'm going to be clear here. The graphing calculator actually does have a pseudo-random number generator. We're not going to worry about that until I explain how at least we're going to create our die, and then I'll show you where the kinks are. And so we're going to start by going into math, and we're going to go over to the probability menu, and we're going to choose random. And you're going to see that if I hit enter, a number appears. This number appears between 0 and 1. It does not include 1, but it does include the possibility of 0 coming out. That's why there's a solid dot there and a hollow dot there. Now, if I keep hitting enter, I'm just going to keep getting, quote, more random numbers. The problem is that's not very helpful for me to figure out, let's say if I wanted to make a die that was from 1 to 6. Now, if I wanted to do, let's say, a coin flip, I could say any number that was less than 0.5 would be heads, and anything from 0.5 and up could be tails. But I really want to have this die because that's what we're going to use most often. And I don't want to have to think of which fraction falls between 0 and 1. So you know what? I want the number from 1 to 6. It would at least make more sense to at least get this to be 6 times wider than it is. And so what I'm going to do now, hit the wrong key there. Let's go to math, go back to random, and times 6, is I am going to stretch, I'm going to apply a scale change to all my outcomes so that now it goes from 0 all the way out to 6. So whatever you multiply by, think of this being the number of different sides to your die. Okay? The problem is you're still getting decimals. We'll get to that in a moment. But at least if you think of times 6, that will be the number of options. If you want to have, let's say, a 5-option test, you would say, hey, I'm going to multiply by 5. Now, I don't want those decimals. But the calculator has a built-in rounding down feature. It doesn't have a rounding up. So I'm going to go math. I'm going to go over to num, and I'm going to choose number 5 for int. That's my rounding down. Then I'm going to go math. And so I'm going to come over to here to probability. I'm going to go random, and I'm going to say here's my number of options, times 6. But because I'm rounding down, I'm only going to get numbers from 0 to 5, because even if it was 5.999, it's still going to round down to 5. Just like 0.23 will round down to 0, like this happened here. Now, you could just say, let's make all zeros the same as 6s. I would have to manually go and change, or I have to write some very fancy code. When in actuality, if I have these 1, 2, 3, 4, 5, 6 dots going from 0 to 5, if I could just shift them over one spot, I could have 0 become 1, 1 become 2, and 5 become 6. Well, there's where we could actually add a translation to this, and I could have a 6-sided pseudo-random die. And that's pretty much how it works. So this number is like your starting number. This is the number of options, and the int is rounding down. Let's take a look at some of these different examples so that you can get a better idea. So if I was to type in on this one, let's start this over. If I go math and I go num and I go int 5, okay, and then I'm going to go math and I'm going to go over to random and I go times 2, I want you to understand that my initial number is like having plus 0. So I'm going to have 0 as being one of my numbers. Then the 2 says I have 2 options. Well, if I start at 0, the next option will be 1, and so I should get nothing but zeros and ones. That could be like true and false statements. Okay, so nothing but zeros and ones as I hit it. Let's take a look at this one over here. If I would go math, go to num, and I go to int, all right, and I go math, and I go random, okay, and I go times 6, I'm still going to have 6 options. 0, 1, 2, 3, 4, 5. But see, in this case, I'm telling you to start at 8. So 8 is going to be my lowest number because I'm shifting the 0 to 8. And that means 1 will become 9, 2 will become 10, 3 will become 11, 4 will become 12, and 5 will become 13. And that's how I get my 6 numbers, 8 through 13. And let's see if I get that. I got 10s, 11s, 12s. There's a 9, there's a 12, there's 11, there's a 9. Haven't seen an 8 yet. There's my 13. Maybe I missed an 8. Let's take a look here. Oh, there's an 8. So it may take a while to get there, just like any die roll. We may not always get the one number we want, but you'll notice that no other numbers came up. So let's just take a look at these other examples. Here I have all these starting at 0 because I have essentially nothing added or subtracted to it. So and then because I have 18 choices, I'm going to go 0 up to my 18th choice, which actually be number 17. And if I say I'm starting at multiplying by 100 and still starting at 0, that'd be from 0 to 99. Over here, I have 11 choices, but I'm going to subtract 5. And if my first number is normally 0, I subtract 5, that puts me at -5. Then I will need to go 10 more choices after that, which will bring me up to +5. Remember, -5 is the first choice. Then I have 10 more choices after that because of the times 11. So here, if I say +1, I'm just going to start literally at 1, and I'm going to count 25 numbers. So 24 numbers after 1 is 25. And that's how you can essentially create a die on your calculator, which is what we're going to use to simulate our different events. Now what I want to get into is the pseudo-randomness. And I would like to explain what happens here. So I have a calculator here that says random, and that number came up. And I'm going to come over here, and I'm going to hit, let's see, hit that, math, and I'm going to come over here, random on that one, and I'm going to hit enter there. And I'm going to hit math on this one. First turn it on. There we go, math. Let's go to random here. And then I went math, and I'm going to go over to random here. Okay, so it looks like all these calculators are random. That's not actually the case. They actually use an algorithm to generate random numbers, but what happens is that the seed is always the same. So when the calculator gets reset, and so let me do this here. There's reset calculator there, debug reset calculator there. Okay. All right. Later calculator, reset calculator. Okay. Now I've cleared the RAM, meaning that I've essentially got the calculator when I first bought it. So I'm going to hit enter, 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 and I'm going to go math. I'm going to go to random, and I'm going to hit enter. I'm going to go math. I'm going to go over to random. I'm going to hit enter. I'm going to go to math. I'm going to go over to probability, hit random, hit enter. And what you're going to find out is when your calculator starts over, you will always actually have the same sequence of numbers. So I don't actually know how many times you've actually played a game on your calculator that required random. I don't know how many times you press random on your calculator. I have no idea. So it is very possible that if you and your friend never used the random feature all ever before, you might end up getting exactly the same results because the numbers should all come up to be the same. So I'm going to give you a suggestion right now. Take your random. Don't look at it. Just feel free to just start firing away on those enters. Now what I did is I wrote this little program. I'm just going to show it to you. So I'm going to go program. I'm going to go edit. And what I did is I clear the screen. It just says random loop. Okay. I'm going to actually keep track of how many times I loop through this. And I'm just going to store a random number into R. And when I run this, I'm basically running this ran thing I just did over here many, many, many times. So here we go. I'm going to go program. I'm going to go ran. I'm going to hit enter. And so right now it's running. So over here I could be hitting enter, 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 which is kind of slow. This is doing it many, 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 many times over here on the left. So I'm truly trying to shuffle this up so that when we do our simulations later on, this will be the case. I think that's good enough. Let's hit, now I just have to hit on a few times before it stops. There we go. So I break the loop, and I'm just going to quit. Just in case you want to know how many times it ran the loop here, alpha L is where I store the variable. It says I ran this 798 times. Now, remember, this is 798 times when I ran this from this one, and I may have run this before that, and I may have run this before that. So I may be up to thousands and thousands of numbers at this point. So in my perspective, I really have no idea what's coming up next. If the calculator would accidentally get reset, then I have a better idea. So I would really, again, recommend that you go through at some point to start firing away at the random numbers so that you can have a good random number generator so that your results will differ than my results. And with that, we'll stop.